problems, I think, are a little more straightforward than the last problem.
Okay, number one. Pretty straightforward. I know you want to go over it. Go ahead.
5 by 50 and 5 by 2.
Okay, so you distributed, right?
Yeah.
It's one way to do it. Good. What's your answer there?
I doing the whole thing.
Sure.
110.
Close. 5 times 50.
Oh no, I thought you meant 5 times 50. I got 100, but I multiplied it by 2 as well, and I underestimated.
Okay. And add those together. Go ahead, Nicole. Number one.
I got 260.
Good. Okay. There's a number of ways you can do it. You can distribute your 5, or an easy way. I'm going to work in my parentheses first. I get 52, and then I know I have to multiply my 5.
Or you just put it all in the calculator.
You can do that too. But make sure in your calculator that you're using parentheses. All right? So you're getting the right answer. And your answer is going to be 260. Okay? Use 52 times 5. If you don't have a calculator there, I can. Okay, 18 plus negative 25. The way that I look at it is if I'm on a number line and I'm at negative 25, okay, I know I have to go over in a positive direction because it's positive 18 on the number line, and that's going to take me all the way to negative 7. All right, or you can do it in your calculator, use the parentheses. I like how they add right there. You get negative 7. We're good on number 2? All right, and then number 3, what is the difference? Who knows what difference means? In a word problem, you see the word difference. Subtraction. Okay? So we know we're going to subtract a little bit, but same thing. The way I'm going to look at this one here too is I'm going to draw my number line, okay? And I'm going to start at negative 5. All right? And then a daily high of 18. So if I'm going from negative 5 to 18 past 0, how many jumps am I going in a positive direction all the way to 18? So what would my difference be? Go ahead, Megan. Positive 23 degrees. Nice job, because I'm moving, anytime I'm moving on a number line in the right direction, positive. If I'm going left this way, it's going to be in a negative direction. All right? Good job on that.
Any questions on those? Anybody like winter when it's 18 degrees outside for a high? Yeah, not really looking forward to those temperatures yet. Maybe we have a delay if it's negative 5 degrees outside. Right? Something to hope for. Maybe a delay. Probably not. Not here, right? No. They'll let you freeze at the bus stop.
They don't wear coats anyway.
Oh, that's true. When they still wear shorts in the winter.
Yeah,
Yeah.
shorts and hoodies.
Yeah, yeah. Mhm. All right, so we're going to talk about numbers today, specifically the different types of real numbers, and then we're going to see if we can graph them, multiple numbers on the number line, and also apply that to some real-world situations. There are two types of numbers. There are real numbers, and then there are imaginary numbers. So there really is something called an imaginary number. No, it's not fake. Does anybody know why an imaginary number exists? What happens that you have an imaginary number? Darius, was that kind of a hand? No. What is it if you have a square root and a negative number underneath? Does anybody remember what happens with that? Can you take the square root of a negative number? Sebastian? No. So if you put it in your calculator and you try and take the square root of a negative number, you can't do it. The calculator says error. That's why imaginary numbers exist. That's how an imaginary number comes from. We're not going to talk about that right now, but maybe close to the end of the year we'll talk about those types of numbers. So real numbers, we have them divided up into two different categories here, so that we can talk about like the types of real numbers. There's something called a rational number. So this is a type of real number. Does anybody know what a rational number is? So a rational number is any number written as a fraction. So Cam, give me your favorite fraction.
1/2.
1/2. That sounds like a really good fraction. 1/2. A fraction is a rational number, the fraction 1/2. You could have 3/4. That would also be a rational number. So any fraction is a rational number. And pretty much most numbers can be written as a fraction. That's why it's at the top, because it's the biggest type of real number. Underneath that, the second type of real numbers, getting a little more specific, is called an integer. So you get more specific as you go down. That means you have the less number of examples to look at. So if a rational number is any number written as a fraction, Nicole, do you have any idea what an integer would be? It is a regular number, but there's something special about that regular number. You said 3 or 4. What other kind of numbers are regular numbers? The other side of the number line. What's on the other side of the negatives? Yeah. So an integer can be positive and negative numbers. So she said 3, 4, but you could also have a -5, maybe a -7. So integers are positive and negative. And there's still a lot of numbers that are positive and negative. How about the last type of number? What other kind of numbers are there? So there's rational, integer, and then the ones that are only positive. What are they called? Emily? You weren't talking. No. Aaron? Begins with a W.
Whole numbers.
Yeah, whole numbers. So we have rational numbers, we have integers, and then we have whole numbers. So Emily, what are whole numbers?
Like 9, 10, 11.
Yeah, 9, 10, 11, 100, 5,000. What's special about all whole numbers, Emily?
Just regular.
They're just regular, they're just positive. So whole numbers are positive. Alright, so all of those are considered real numbers. The top would be the broadest, the bottom is the most specific, because they're the least number of just whole numbers. Now there's still an infinite number, but not nearly as many as like the right-hand fraction form. On the right side, there's only one little box here. I have rational numbers. All of those can be written as fractions. But there's still other numbers that exist, and they're called irrational. If you look at the front cover of your packet, I think there's a pi symbol on there. And it says be rational, get real. So the I is the imaginary number, the pi is a irrational number. This is a number that is only going to be a decimal. It cannot be written as a fraction. So one example is the number pi. Does anybody remember what the number pi stands for? From geometry last year? 3.1, you're so close. 4. 3.14. So this is 3.14, but then if you plugged it in your calculator, it goes on forever. So then it's 3.1415, blah, 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 blah. It can never be written as a fraction, that's why it's called an irrational number. Pretty much any random decimal, like 7168544, as long as it doesn't have a specific pattern, like 0.25 can be written as a fraction. It is considered an irrational number. Questions? So we're going to look at a couple examples. God bless you. If you go down to the bottom of the page. Here we have a number line. Sorry, not examples yet. Just a little bit about a number line. We've kind of talked about this already. A number line has an origin and it has a coordinate. What's the origin of anything? Like an origin of a graph. What represents the origin? Read, you know? What would be the origin? 0, yeah. So the origin is 0. Pretty much it's the center of your graph, the center of your number line. So when we graph, we have a center, the origin is at the center of the xy axis. On a number line, it's at the center of 0. A coordinate is just a point that matches with the number line, or a point on the number line. So if I had a point right here at 3, my coordinate would be 3. Alright, so now we can look at some examples. And this is where if you have a calculator with you today, if you can get it out to help us with some of these problems, that would be awesome. So the directions want us to graph the numbers, they're real numbers. We have -5/3, the square root of 2, and 2.6. This is a rational, the square root of 2 is irrational. It can't be written as a fraction, and then 2.6 it is a decimal, but it also could be written as a fraction. So we want to try and graph them. What do you think you'd have to do with -5/3 to try and figure out where I'm graphing that on a number line? Yeah, we need to divide it. So if you have your calculator, some of you that do, in your calculator take -5 divided by 3. And Lana, what did you get when you took -5 divided by 3?
-1.6 would be.
Yeah, -1.6, and when it repeats, you can put that little hat on the top of it. So that's -1.6. And then we have the square root of 2. So if you could put the square root of 2 in your calculator, need help putting the square root of 2 in your calculator? Jared, what'd you get when you put the square root of 2 in? 1.41. So now I have decimals, that makes it a little easier to graph on the number line. So the first number is negative 1.6. Darius, do you know what two numbers negative 1.6 is going to be in between? Yeah, so it's going to be in between negative 1 and negative 2. So somewhere in between here, I'm going to put a point. And then above that, I'm going to write the original number, negative 5/3, just so that I know that what is associated with that point. So it's negative, we need to go left. It's in between negative 1 and negative 2. David, how about the second one? The square root of 2 is 1.41. What two numbers would that be between? I'm sorry, Kevin. 1 and 2. So between 1 and 2, put a point. Again, I'm going to put the square root of 2 on top of it. And then Aaron, how about the last one? Where's 2.6?
In between 2 and 3.
Good. Maybe a little closer to 3 than it is to 2. And then I have 2.6. Any questions? So why don't you take a look at the word problem. I'm going to skip the next example too, but let's look at that word problem. The table shows a record low temperature for the 5 months in the South Pole. Use a number line to order the temperatures from lowest to highest. So they give us from May to September, and we have negative 109, negative 117, negative 113, negative 108, and negative 111. When we look at the number line, it's not numbered for you. We have to decide how to number it. What do you think you need to think about if you're numbering a number line when you have really negative numbers like we have up here? So what do we want to look at to decide how to number it? Ed, what do you think? How would we decide where to go with this number line? Yeah, so we are moving, yes. And what do you think is like one of the important numbers we need to think about? So we need to think about the biggest and the smallest numbers that are up here, because that's going to help us also number the number line. So does anybody know which one is the smallest number? Negative 108. And then how about the other one? Negative 117. So Nicole, which one of those is going to go on the left? Which one's going to go on the right? Right, correct. So negative 117 is farther left, because the more left you go, the bigger the negative numbers are going to be listed. Negative 108 would be farther to the right. It actually is getting closer to 0. So further away from 0 left, closer to 0 on the right. So I'm going to start this at just one less. I'm going to start it at negative 107. And I'm just going to list these numbers. I'm going to extend mine a little bit here. And then see if you can plot your points. So you're plotting negative 109. It's an exact number. It's not in between anything, so it would just go at 109. So see if you can plot those points. If you counted by 2s, that's okay as well. So you could have counted by 2s if you wanted to. But we don't need to include 0 in this number line. So we're way far away from 0. The next part says to use the number line to order the temperatures from lowest to highest. So if I went lowest to highest, which side of the number line do you start on? The left side. So the left side would be lower temperatures than the right side. The closer you are getting to zero, the higher the temperature it is. So start from the left, move your way to the right when we're talking from lowest to highest. So make sure you're doing this. It's the other thing that they're asking you to do with the problem. So I have negative 117, and then I have a point at negative 113, a point at negative 111, negative 109, and negative 108. So it's a two-part problem. We're putting numbers on the number line, points in the number line, and then we're also rating them from least to greatest. Does anyone have questions? So I'm going to skip the two problems, the definitions at the bottom, but I think there are like 4 problems on the next page. There's 2 keywords here. We have difference and quotient. What's difference mean? Subtraction. So difference means to subtract. It wants us to find the difference of 4 and negative 9. Who said subtraction? Jerry, was I? Oh, Cameron. So Cameron, if I want to find the difference of 4 and negative 9, how would I write that? How'd you get that? You're right.
Negative 9 plus 5 is 4.
Yeah, or you could say 4 minus negative 9. And then he said this becomes a plus. So let's look at that again, Cameron. So if I have 4 minus negative 9, what's that actually become? What's 4 plus 9?
Oh, what's 4 plus?
Yeah,
Or 13.
13. So that actually becomes a plus because you're taking a negative of a negative number. If you look underneath it, again, it says the difference of 3 and negative 6. So we have 3 minus a negative 6. So Emma, when you have a minus and negative, what happens with that minus negative? It becomes a positive, and 3 plus 6 is 9. Good. What's quotient mean? Yeah, good. So she said the answer of a division. So quotient means to divide. So we're going to take negative 15 divided by 1/3. Does anybody know when you're dividing by a fraction? Does anybody remember what you actually are doing when you're dividing by a fraction? You're multiplying by what?
The number of the denominator.
Yeah, by the number in the denominator. So when you divide by a fraction, you're actually multiplying by the number in the denominator. So I'm going to change this into a multiplication problem. So when you're dividing, you actually are multiplying when you're dividing with fractions. Bree, do you know what negative 15 times 3 is?
Negative 45.
Good. Awesome job. And then the last question says negative 20, the quotient with 1/4. So really, we're taking negative 20 times 4. And I think it's Jim, right? Jimmy, what's negative 20 times 4? Excellent. Negative 80. Any questions? So we're going to, I'm going to pass some graph paper out, and I want us to at least write the homework down. Not all of it. There will definitely be worksheets as well. But I would say, like, keep your book at home, and then you have it there. It just kind of depends.
Just so I know if I need to.
You don't need to bring it here because I have a bunch over there. Yeah. All right. So your homework tonight. It's on the board. It's also on your assignment sheet. It's page 6, 21 to 29 odd, and then 33, 35, 36, 38, 51 to 57 odd. So pretty much you're going to be doing them on the graph paper. If you look at number 21, again, it's just plotting 2 points. Same thing with number 23, it's just plotting 2 points. So you have the number line there, you just need to make your number line. On the back of the yellow assignment sheet is the directions to sign up for Remind. And that's the app that I'm going to be using to send you reminders about tests or bigger assignments that are due. If you have your phone with you, take it out and sign up for Remind. I'm going to try and get iPads in here or laptops in here sometime next week so that I can show you a little more with the Google Classroom and also the online version of the book, but I need to try and find iPads. And if you've got your phone, you can take it out and sign up for Remind.
All the teachers had that now.
Yeah, well, it's a free app. Mr. Long, you set it up with yours. Yes?
Yeah, I use it for coaching and the other class too. Students are on their phone all night anyway.
Where at? Yes.
Here, just text us.
Yeah, I think it's easier to just text this year. I think that's the easiest
Then
thing to do.
message the
Yeah.
code.